Okay, so before I start, can I just get a feeling for where people in the room are in terms of how many of you have been analyzing next-gen sequencing data forever and you're just here for the omics stuff? Okay, nobody. How many are beginners, the other end of the spectrum? You're just brand new to this? Okay, good. Okay, good. That's sort of what I assumed. So I hope that I don't insult anybody by going a little too basic to start, but I figure I can always start slow and build up. So the agenda for this evening is we're going to start with this introductory session, which is just going to cover some overview topics related to next-gen sequencing and a little bit about the various assays that you can do with next-gen data. And then we'll introduce the idea challenge set, and the information that's in blue will be before dinner. And then the information in black that comes next will be what we'll cover after dinner, where we actually get into the analysis of that particular data set from the idea data challenge. So the basic premise or the main difference between next-gen sequencing technology and Sanger sequencing is that the sequencing actually happens on a fixed substrate. So the sample prep for your next-gen data is going to look very similar to what you have for next-gen, for your Sanger sequencing. You're going to isolate your RNA, your messenger RNA, your short RNA, your DNA, or you may potentially enrich. And I've got a couple of slides on target enrichment or genomic partitioning a little bit later. So you'll isolate your nucleic acids of interest from your samples. If it's RNA, you will reverse transcribe that to DNA. And then you have to fragment those samples, and that's usually done enzymatically or with ultrasonic sonification like Covaris. And then if most of the next-gen sequencers, there is an amplification step at the end, and there's a potential to introduce bias in there. So who's currently today, Illumina, Ion Torrent, Solid, and Roche 454 all involve this library amplification step. And then what is often referred to as next-gen sequencing are these single molecule sequencers. And those in general do not require a PCR amplification step at the final end because you just isolate and fix those to the substrate. And you fix them to the substrate using adapters. And so those adapters are usually attached via PCR or chemically. So those adapters will bind to a solid substrate. Usually there's flow of reagents or ACTGs that go across those fixed, those sequences that are fixed on that substrate. The sequencing happens in place. Those are all, output is read in real time. That's the massively parallel. So when this happens in a tube for your Sanger sequencing, you're sequencing lots of fragments at the same time as well, but you're not reading it out in real time. And if there are ever any questions, just please feel free to stop me and interrupt me. So next-gen sequencing is, if you read some articles, they'll tell you that microarrays are dead because next-gen sequencing is the greatest thing since sliced bread. And indeed, there are several advantages to doing next-gen sequencing. The biggest advantage is it's template-free. So it's kind of like a drunk looking for his keys in the light, right? When you use microarrays, you can only find where you're looking. And so when you use pre-printed templates or probes on a microarray, you're only going to find what was printed on your microarray. For next-gen sequencing, that entire constraint is removed, and you can basically find whatever you isolate.